Hi, my name is Arad and I lead the Functional Hybrid Materials Lab at the Technion. In our group, we study hybrid materials, a fascinating class of materials that combines the best of both inorganic and organic components. The inorganic part provides functionality and stability, while the organic molecules bring enormous flexibility and diversity. By combining the two, we can create materials with properties that are difficult to achieve in conventional materials. Two important examples are hybrid perovskites and metal-organic frameworks. These materials have attracted a lot of attention in recent years because of their optical, electronical, and structural properties. They are being explored for applications ranging from LEDs and sensors to water purification and CO2 capture. For decades, hybrid materials were thought to exist only as crystals. Only within the last few years, researchers discovered that some of them can also form amorphous structures. By melting the crystal and cooling the liquid fast enough, crystallization can be avoided, and a completely different solid state can be obtained. These disordered materials, known as hybrid glasses, are very much different from the standard glass we know from our day-to-day life. They often exhibit properties that are very different from those of the original crystal, that open an entirely new area of research. In the Functional Hybrid Materials Lab, we study these hybrid glasses, how they form, what properties they have, and how they can be used in future technologies. Our research sits in the intersection of chemistry, physics, and material science. One major direction in the lab is understanding the thermodynamics of hybrid glasses. We investigate how these materials form, why they recrystallize over time, and how their stability can be controlled through chemical and structural design. In other words, we are trying to understand how disorder emerges in hybrid materials and how it can be deliberately controlled and manipulated. A second direction focuses on discovering new glass-forming hybrid materials. We synthesize new compounds, study their structure, and investigate how their thermal, optical, and other functional properties change when they transform from a crystal to a glass. Ultimately, we want to develop general design rules that allow us to predict which materials can form stable glasses and what properties they will have. A third direction explores how melting and glass formation can be used as entirely new ways to process materials. Instead of relying on traditional fabrication methods, we investigate how hybrid materials can be shaped, cast, and manufactured directly from the melt. This opens exciting opportunities for new processing strategies and potentially new optical and electronic devices. To answer these questions, we combine chemical synthesis with a wide range of advanced characterization techniques, including thermal analysis, X-ray diffraction and scattering, spectroscopy, and microscopy. We also regularly travel to synchrotron facilities around the world, where we use extremely intense X-rays to study how atoms are arranged inside the material, both in the local scale and across the overall structure. Students in our group are involved in the entire research process, from designing and synthesizing new materials to performing advanced experiments and uncovering the relationships between structure and properties. This creates a highly interdisciplinary environment that combines chemistry, physics, material science, and engineering. So if you're curious about how materials work and enjoy hands-on experimental research and would like to help discover and understand new class of materials, I would be delighted to hear from you. Feel free to contact me directly for more details.